Okay, so let's start 8.3 day 3. And we have to start this off with polynomial long division. I know we did this first semester and you probably thought you were never going to have to do this again in your life. But guess what? You have to do it for today's lesson. So let's recap what you know about long division. So the first number is what goes underneath the long division symbol. Okay. And then if there's any skips or missing terms in the middle, you must put in zeros for them. So don't forget your skips. Okay, so we've got x cubed plus x squared minus 16x minus 20 in this first one. And x minus 4 over here. Actually, I'm going to do that in black ink. Okay, so here's our equation. You may ask, like, hey, Mrs. Roeder, why can't I just use synthetic division? Which technically for this problem you can, but in most of the problems that we do for this unit, then you have to do long division. It's not going to work with synthetic division, so long division, it works every single time. So I'm just going to show you the long division way just to recap, because like I said, it works every single time and you don't have to think about flipping back and forth. And it's really not that bad. They give you short problems. They're much shorter than this even, so it'll be okay. All right, so here we go. We've got x times what gives you x cubed. So that would be x to the second power. So we're going to put that in the x squared column. Multiply it back. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. All right, let's go ahead and subtract. Remember, you got to distribute that negative. The x cubes cancel, and then you have x squared minus negative 4x squared, which would give you positive 5x squared, because it's minus negative. Drop down the negative 16x. X times what gives you 5x squared? That would be positive 5x. Multiply it back. So 5x squared minus 20x. Okay, let's go ahead and subtract. X squareds cancel. And then that would end up being positive 4x minus 20. All right, let's do it again. X times what gives you 4x? That would be positive 4. Multiply it back. So you would have 4x minus 16. And then go ahead and subtract it. Then you would get the remainder of, I think that's negative 4. So you would write it as plus negative 4 over x minus 4. Long division. Not that bad. It takes a little while, but you'll be all right. Okay, let's do this one. So there's a skip in this one. There's actually two skips. So the term, the dividend, has a skip at x squared. So I'm going to do plus 0x squared minus 23x minus 8. And your divisor also has a skip. So it'll be x squared plus 0x minus 5. Okay, x squared times what gives you x cubed? Well, that's easy enough, right? It's just x. So that's going to go over here in our x column. Multiply it back. So you have x cubed plus 0x squared minus 5x. Then let's go ahead and subtract them. So that's 0x squared, right? Which is just 0, so we don't need to write that. And that would give you negative 18x minus 8. How many times does x squared go into negative 18x? It's not going to. So that's actually your remainder. We're already done. So it's going to be plus negative 18x minus 8 over our divisor, so x squared minus 5. That would be your answer. Okay, I'm going to skip these other two just to save time on this video, but don't worry if you're kind of rusty on that. We're going to have lots of more chances to do that these next couple problems. All right, so now we're actually on the day 3 notes. So just to recap what you did from the day one and you did or on the day two notes as well. So horizontal asymptotes. So there can only be one or none. So for this stuff that we're doing in this class. So if the degree is larger, so if the top has a larger degree, oh, I'm sorry, smaller. I can't even read my signs. Sorry. If the top is smaller, my bad, then the horizontal asymptote is y equals 0, aka the x-axis. If the degrees are equal, then you use their coefficients. And then if the top is bigger, there is not a horizontal asymptote. Okay, so now we're going to have a different kind of asymptote called a slant asymptote. You may also see it called an oblique asymptote. Don't freak out. Slant, oblique means the same thing. It depends on what textbook you're looking at. So these are literally going to be a slant. It's going to be an equation of a line. That's going to be a new asymptote, which is fun. So when do these slant asymptotes occur? So it occurs if the m minus n, the degrees, when you subtract them, is 1. AKA, and something that makes a little bit more sense, I think, if the top is 1 degree, oops, can't spell degree, weird, degree larger, then you have a slant asymptote. Okay, so the top is 1 degree larger, it's slant asymptote. To find the slant asymptote, you have to use long division. So whenever you do the long division, your answer, your quotient, is your equation of your slant asymptote. And the fun part of this is the remainder does not matter. So if there is a remainder, it doesn't affect it. Okay, let's do one. Here's our first problem. Let's start out by factoring this. So this will be x times x minus 1 over x plus 1. Start with all the stuff. We'll do slant asymptote at the end. Because as you can see, the top is 1 degree larger than the bottom, so there will be a slant asymptote. But we'll worry about that in a second. So holes, there are none, right? Vertical asymptote looks like there's 1 at -1. Horizontal asymptote, the top is bigger, so there's going to be none. X-intercept is going to be when you set the numerator equal to 0. So if you set x times x minus 1 equal to 0, you're going to have two answers. You're going to have x equals 0 and x equals 1. So we're going to have two x-intercepts on this. So 1 at 0, 0, and 1 at 1, 0. Okay, and your y-intercept is when you plug in 0 at the beginning. So you would end up with 0 in your numerator over 1. 0 over 1 is 0. So this would be at 0, 0. Okay, now the fun part, slant asymptote. Like I said at the beginning of this problem, the degree of the top is 1 larger than the bottom. So there will be a slant asymptote. So we get to do long division. It's really not that bad. It's going to be like these are pretty easy ones. Like they work out nicely. So our divisor, and you start with the original problem. Don't do factored form because then you'll just have to distribute it out. It's a mess. So x squared minus x, and there is a skip at your constant, so plus 0, divided by x plus 1 is your divisor. Cool. Let's do it. So we've got x times what gives you x squared? X. Multiply it back. You get x squared plus x. Let's go ahead and subtract them. The x squareds cancel. For x, you get negative 2x plus 0. X times what gives you negative 2x? That's negative 2. Multiply it back. Negative 2x minus 2. Go ahead and subtract it. So that would end up being positive 2. So that's your remainder. But, like I said earlier, the remainder doesn't matter. It doesn't affect things. This is your equation of your slant asymptote. And if you notice, it's an equation of the line, which is what we need. So your slant asymptote is going to be y, you must say y equals x minus 2. All right, that's just an equation of a line. So let's go ahead and graph it. Graph the stuff we have, and then we'll pick our points. So y equals -2. Let's start there. So go to -2 on the y-axis. And it has a +1 slope, so do that. Okay. So, and I like to make mine dashed so they stand out and I don't get confused. All right, then we had a vertical asymptote at -1. And then we had a no horizontal, and then the x-intercepts were at 0, 0, and 1, 0. I believe that's it. Okay, so let's pick some points. So, again, I'm just going to pick some points that I've already picked in class. Please type these in your calculator. If you don't, you're going to struggle on the quiz and test because you're going to be stuck and you won't know how to do it. And then you're going to ask me for help, and I won't be able to help you because it's a quiz and a test. So please take the time to make sure you can type it in your calculator because it is a skill. Calculator, it's a skill to work with, but I'm going to speed it up for this video and the time. So -6 is going to give you -8.4. -4 is -6.6. -2 is -6. And 2 is 2/3. And 4 is 2.4. And it doesn't matter that I have some in fractions, some are rounded decimals. It doesn't matter because we're sketching it. As long as you're in the ballpark, it's going to work. Okay, so now let's go ahead and plot all this. So -6, -8.4 would be about right there, I think. And then -4, 6.6. -2, -6. 2, 2/3. And 4, 2.4. Okay, so I know what this graph looks like because I've graphed a lot of these, but if I were you and I was just learning this and I wasn't quite sure, you might be tempted to just do something like this. And this is not correct, okay? So I'm going to pick another 2 points and I'm going to try to get even closer to that x-intercept or that x-asymptote. Sorry, vertical asymptote. Okay, so let's pick another point that would get closer to the vertical asymptote on the left. So something over here. Let's try picking -1.5 because that would be just a touch closer. And I'm not, you're probably not quite sure what's happening on this graph. So we're going to pick some more points. It happens sometimes. And then on the right side, let's try to get closer on the right side. So let's pick -0.5. Okay, so you can also pick fraction or decimal x-coordinates. It's definitely allowed. Okay, so please type these in your calculator, but I'm just going to tell you what the answers are. But make sure you are confident, especially with decimals, because they can be tricky. So -1.5 will give you -7.5. And -0.5 will give you 1.5. So let's graph these. So -1.5 and -7.5. -0.5 and 1.5. Okay, so I'm glad I did that because that gave me an idea of what this graph is going to do. And this one's actually pretty close to your asymptotes, both your slant and your vertical. So it looks something like that. Okay, kind of cool. Looks cool. Okay, let's do, I'm going to do one more. So h of x, the second one. Start by factoring the top. It'd be x times x plus 3 over 2x plus 1. All right, wholes, there are none. Vertical asymptotes, that would be what? -1/2. Horizontal asymptotes, there's none because the top is bigger. X-intercept, this is really similar to that last one. The x-intercept is, you set the numerator equal to 0, so there's 2 of them, so 0, 0, and negative 3, 0. Your y-intercept is 0, 0. And your slant asymptote, we don't know. We need to do fun long division. Okay, so let's do it. There are skips in your divisor, or your dividend, excuse me. So x squared plus 3x plus 0 divided by 2x plus 1. This is a fun one. Okay, so 2x times what gives you x squared? Or another way, if it helps you, if that's like, what? 2x times what gives you x to the second power? So you know there's got to be an x in there, right? So we can just literally do basic algebra. Divide both sides by 2x, divide by 2x. Those cancel. Your question mark is x, one of the x's cancel because you have x squared on top over x. So this would be 1, or we'll write it this way. X over 2. Or since we're going to be writing an equation of a line that's going to be in slope, let's write it as 1/2 x. The reason I do that is that way you can see the slope. Hey, the slope is 1/2. Just a little bit more line friendly. So 1/2 will be in this, 1/2 x. Let's multiply it back, make sure it cancels. 1/2 times x, or 1/2 x times 2x would give you x squared. Good, we did something right. 1/2 x times 1 is going to give you 1/2 x. No big deal. Let's subtract it. So the x squareds cancel, and you get 5/2 x plus 0. Okay, this is a little gross, but you're okay. So 5/2, let's do our little cheat sheet again. I think it helps some people if they struggle to see it. So 5/2 times, or sorry, I'm doing this wrong. 2 times what is going to give me 5/2? Well, we're going to either divide by 2, or we can multiply by the reciprocal, which is 1/2, which is what I'm going to do over here. Multiply by 1/2. Those cancel. Your question mark is 5/4. So that is what's going to go up there. So positive 5/4. Let's multiply it back just to make sure. 5/2 times 5/4 times 5/2. I'm sorry, let me rewind. There's a lot of numbers saying. 5/4 times 2 would give you 5/2 x. And then 5/4 times 1 would give you 5/4. Let's go ahead and subtract. And you get negative 5/4, which is your remainder. But again, we don't care about remainders for this. So that is your equation of your slant asymptote. Yes, it's kind of gross, but it happens sometimes. So you're just going to have to be prepared for it. And just keep doing practice. But we need to write it nicely. So it'll be y equals 1/2 x plus 5/4. Okay? All right, let's graph this. Let's start, I'm going to do my slant asymptote first. It's a little hard to do these because they're fractions, but we're just going to make it work. So 5/4 is like 1 1/4. And then the slope is 1/2. So up 1 over 2. Do that a few times. And then I'm going to also go in the reverse direction just to try to make it as neat as possible. Draw my asymptote with a dashed line. Okay, now let's graph the rest of it. I had a vertical asymptote at negative 1/2. This problem just has so many fractions. Okay. So we got that. The x-intercept and y-intercept was at 0, 0. And then also we had an x-intercept at -3, 0. Okay, I know that's really close to the line, but it's actually, it should be above the line. I should draw that a little bit better. Let me erase that. Maybe if it'll erase. Why is this not erasing? Okay, there it goes. So it should be negative. Sorry, I'm having technical difficulties. Above the line. All right, so let's pick some points. Again, try picking your own points and see, like, pause the video, pick your own points. You didn't pause the video, did you? Of course not. Okay, I'm going to pick the following points because I've already done it. -10, you get -3.7. -5 is -1.1. -1 is 2. 1 is 4/3. 2 is 2. And 5 is 3.6. Okay, so let's go ahead and graph it. So -10, -3.7. Pretty darn close to that line. But it's not, it's staying above it, just barely. -5, -1.1. -1, 2. Okay, that kind of gives me an idea. 1, 4/3. 2, 2. And 5, 3.6. All right, so that looks something like this when you draw it. Oh, that left side's not quite as pretty, but it'll do the job. Okay, so there is your graph. Kind of cool. Say you're taking a quiz or a test and you completely forget all of these rules. When in doubt, pick a ton of points. You could literally pick every single point between -10 and 10 and see what you get and make a table, and you should be able to get an idea over what the graph will look like. Okay, that is it for this lesson. Thank you for watching. Have a great rest of your day.